Okay, folks, so today we're just doing a little bit of review, but there will be some new information. So if we look at the problems, we're not doing these 15 through 20. We're going to start with number 21 right here. It says, what is the mass of exactly 1 mole of calcium acetate? Well, we should look up calcium acetate like that. And right here, here's calcium acetate right here. Okay, so it's a C4H6CaO4. So CH6, let's write that down. CH6CaO4. Let me make sure I didn't miss anything here. No, C4, yeah. I missed the 4 and the C. I thought I missed something there. So that's a 4, by the way. Sorry. So there's a total of 10, 11, 15 atoms for this one molecule, okay? Just give you that heads up there. And if we go back to the actual assignment, it says, what is the mass of exactly 1 mole of this? So to do that, you guys should remember that you're going to need to know the molar mass of it, which means you'll have to look up carbon, hydrogen, calcium, and oxygen, so C, H, C, A, and O, and write the mass of each one, timesing it by 4, timesing it by 6, timesing it by 1, and timesing it by 4. And then find out what all these are. That'll give you the total mass of each one of those. And then this will give you how many grams per mole. It'll give you the grams per mole of that substance. And it says, what is the mass of 1 mole? Well, then that's the answer, because this is how many grams per 1 mole. Okay, so whatever this answer is here, that's your answer, because that's how many grams are in 1 mole. That's what this value means. So pretty straightforward for that one. How many moles are contained in 1.58 grams? Well, then you'll have to take 1.58 grams and divide it by that value. It's going to be a small amount, no doubt. It's going to be less than 1. It's not going to even be 1 mole, because I can guarantee you the molar mass is more than 1.58 with all those atoms in there, right? How much does 0.4 moles weigh? Well, for that, you're just going to be multiplying. And write the formula for oxygen gas. That one I can tell you right now, I won't look it up. Oxygen is that's an atom. That is oxygen gas that you breathe in. And if you have 3 of them attached, that's ozone. Like the ozone layer on Earth. It's not very healthy at all to breathe. It's good to have up in the upper atmosphere. It blocks UV rays and stuff from entering the Earth. But it ain't healthy to breathe. Okay, so this is O2 gas that you would think of to breathe. Okay, so that's easy. It's just 2 oxygens. All right, and then how many atoms and moles are represented by the formula in that? So there's 2 atoms, right, and 2 atoms of oxygen, and then moles are represented in the formula for 24. I don't know about moles. I don't think you can answer that, but it's just 2 atoms. What is the mass of Avogadro's number of oxygen molecules? So think of the 2 oxygen molecules. There's 2 of them. And it says, what's the mass of Avogadro's number? Remember, Avogadro's number is a mole. So they're asking for what's the mass of 1 mole. So it's going to be about 32. Yeah, just check your answer, but it's going to be about 32. Because the periodic table, just look up the mass of, you're pretty much finding the molar mass is all you're doing, because it says, what is the mass of Avogadro's number of oxygen molecules? That's the same thing as saying, what is the mass of 1 mole of oxygen molecules? And just like up here, when we had to find 1 mole, right? The mass of 1 mole, all we're really doing is finding the molar mass, because 1 mole is 1 molar mass, so that's all you have to do. To find a mole, go ahead and look that up. How many moles are present in 34 grams of this? So remember, if you're trying to find those, we've done problems exactly like this. So what you have to do is, and I'm not going to solve it for you, you'll have to solve it, but in a sense, they're giving you a certain amount of grams of something. Let's say 30 grams of, and I'm just going to go O2 to make this easy for me. I'll do carbon dioxide. How about that? Carbon dioxide. So how many? So they want to know how many moles there would be of this, right? So what you have to do is first break this down, and then go, okay, carbon, the mass is, and you'll have to go to the periodic table for that. I already know what it is, so it's 12. It's about 12, and this one's about 16. Okay, I think it's 15.9, and this is 12.011 or something like that. But let's make the math easy and just round them. And but we're going to times this by 1. We're going to times this by 2 because there's 2 oxygens. There's 1 carbon. So this is 12, and this is 32. And that's going to give us a 44. Okay, that's how many grams there are per mole. So if somebody asks you, what is the mass of 1 Avogadro's number? The answer is 44. If they say, what's the mass in 1 mole? The answer is 44 grams as well. But that's not what they're asking. They're asking for how many moles are in this. So how many moles? And we've done this before. Well, we already know there's 44 grams in a mole, but they only have 30 grams. So obviously I don't even have 1 mole, but how much do we have exactly? That's easy to do. Just take this number and divide it by that number. And that'll tell you how many moles you have. For example, if this was 88, you would put 88 here divided by 44, and you would have 2 moles. That makes sense. Okay? If this was 22, and you put 22 here, that's only half of the 44, you're going to get 0.5. So 0.5 moles, or half a mole, right? So let's go ahead and calculate what this is. Let's get out a calculator. I put calcium acetate again. And we're going to do 30 divided by the 44 is 0.68. So the answer to this would be 0.68 moles of CO2. So that's exactly what you'd be doing for this assignment right here, where they said, where were we? Right here. How many moles are there in 34 grams of this? The only thing is you have to figure out the molar mass of that first, instead of CO2. How many moles are present in this? Well, for this problem, if you remember earlier, you don't care about this. CCH4, I don't care what this is right here. It doesn't matter what that chemical is. If I have this, let me see if I can highlight it. If I have that many molecules, then that's a certain amount of moles. Think about it. If that number right there that I just highlighted said 6.022 times 10 to the 23rd, I would have, and I already know the answer. I'd say, oh, that's 1 mole. You have 1 mole of that stuff. But this is not quite 6.022 times 10 to 23. It's like 2.4, so it's going to be less than 1. So all you're going to do is figure out how much. So, you'll just take whatever it is. Let's say they said 3 times 10 to the 23 and divide it by the 6.022 times 10 to the 23rd moles. And you'll say, that's an Avogadro's number. And this will tell us how many moles we have. It's not going to even be 1. For this one, it's going to be like 0.5, about 3 divided by 6. This one is pretty much just take this number divided by Avogadro's number. That'll tell you how many moles you got. How many grams are there in this molecule? So this one I'm going to need to know. I need to look up the molar mass of that. I'm going to have to do that little thing where we put the N and the H and figure out how much mass each one is. Have to do that. And then we have the molecules here. So just look at the past assignments and you should see the work for these. We've done all of these. This is like a review day. How much does 4.2 moles of this weigh? This is one we've done in the past. Go ahead and figure out the molar mass of this. Be careful that NO3, once you figure that out, you got to times that by 2 because it's in parentheses. Then add in the calcium weight too. So add all that in. And once you know the molar mass, just times it by 4.2 moles. Because remember, once you find the molar mass of that, that's how many grams there are per mole. And then times it by the 4.2 moles, that'll tell you how many grams there are total weight. And by the way, the weight and the mass, they are technically different if you know science and you know the exact difference, but in this realm, they're exactly the same for us. What is the molar mass of MgO? So magnesium oxide, I guess, MgO. It's a magnesium and oxygen. It's only 2 atoms there. What is the molar mass? We'll look up magnesium, look up oxygen, add them up, and write it down. Pretty easy. That's a super simple one. How are the terms of molar mass and atomic mass different? Here's where we got something new here. And it has to do with AMU and grams per mole. And let me just clarify this, okay, so that you guys know this new information. No, don't resize new. No. Okay, so let's say we're looking at, I don't know, helium 2,4. Okay? This is the atomic mass. If somebody said, how heavy is that atom? This atom, just that one single atom, how heavy is that atom? I would say it is 4 AMU, atomic mass units. Because a proton equals 1 AMU, and a neutron equals 1 AMU, atomic mass unit. And there's 4 protons, 4 neutrons, and that means there's 4 atomic mass units. That's how much that single atom weighs. If somebody said, let's see, 92, uranium 235. This is the radioactive one isotope of uranium that you would use to make nuclear bombs. If somebody said, how much does an atom weigh? One atom of this. And so if they said, how much does this one atom weigh? If somebody said, what does one atom of uranium weigh? If you're a chemist, you'd say, well, what isotope? Because I need to know what isotope. This one's 235, so it weighs 235 atomic mass units. The more stable and more common form of uranium is uranium-238. It weighs more and it's more stable. And if somebody said, how much does this one weigh? I would say this uranium weighs 238 atomic mass units. So atomic mass units are what you use to figure out the weight of a single atom, and they're whole numbers. So 5, 6, 7, 8, 300, whatever. Okay, the point is it's a whole number. Now, when I find a big old block of uranium, okay, so I find this big block of uranium, whatever. So this is a block of uranium. It's pure uranium. Man, look at this chunk of pure uranium I have. I wonder how much the atoms weigh. Well, there's a bunch of different atoms in there. There's probably mostly this kind, but there's going to be some of those in there as well and stuff like that in this big block. And so what we do is you would go to the periodic table, and I didn't have it here, but let me see if I can pull it up. Uranium is here, and it says 238.03. That's the molar mass. That's the molar mass. 238.03. This is how many grams per mole. Okay, and what it is, it tends to be an average of all the junk in there, all the different types of uranium isotopes. It's the average of all of them, and it tells you how many grams you would find per mole. It takes account everything, though, every single thing that you would find in here, as far as all the different uraniums and how much it would totally weigh. This is how many grams per mole it was. A single atom, you would just measure in atomic mass units. They tend to be pretty close to the same, though. These two are pretty much end up being the same, the molar mass and the atomic mass units, but they are technically different, and that's what I just wanted to explain to you guys. So that's it, folks. You know what your assignment is. Go ahead and work on that now.